Alright everybody, some people might be a little stressed out with IPv6. Don't let it get to you. It's not meant to be that crazy. So here in this lab 1266, we get a quick view of IPv6 with a rather straightforward configuration walkthrough here. Everything is pretty much provided. We don't have much additional thinking to toss into play here because it tells us what to do. So let's get started by identifying our networks. Well, we've got R1 here, which separates three networks. We've got a network to the left, which is 2001 DB811 double colon, where double colon means all zeros with a /64. Well, what does that mean to us in English? Well, what that really means is something we could break apart right now. So I'm going to open up a Word document here, and we're going to get started with that subnet 2001 DB811. So I've got my Word doc open here, putting it on the right side, and that's play. With this subnet, where's the network portion, where's the host portion, and all that? Well, we're given 2001 DB811 double colon /64. So what does that mean again to us? Well, if we expand this using our Rule 1 and Rule 2 of IPv6, this really means 2001 0DB8 0001 0001, and then the double colon, that's all zeros. But how many zeros? Well, in IPv6, we have 8 hextets. We only have 1, 2, 3, 4 displayed here, so we need 1, 2, 3, 4. It's 5. 1, 2, 3, 4. 6. 1, 2, 3, 4. 7. 1, 2, 3, 4. That's 8. And guess what? I gotta make my font size a little smaller now, so it all fits. But this /64, what does that mean? Well, that's talking about network portion versus host portion. So what's the network? What's the host? Oh my goodness. Well, in IPv6, it's meant to be easy. Each character in hex is worth 4 bits. 4 bits. So we count by characters. 4, 8, 12, 16. That's 16 bits in. 20, 24, 28, 32. That's 32 bits in. Or if you catch the little pattern that's happening here, what's really occurring behind the scenes is the fact that each of these hextets is worth 16 bits. 16, 32, 48, 64. With 64, that's saying that this is our network portion, which means the remainder is the host portion. So the network on the left is defined as 2001 0DB8 0001 0001. Well, how does that different than this network, 2001 DB81264? Well, it's actually rather straightforward. We can actually take this entire thing and say this is one network, and the second network is 2001 0DB8 when we expand it, 0001 when we expand it, 0002 is the second network. So really what we're doing here is we're just changing this host portion as we put users on the network, but the networks are different because the one network is a 001, the other network is 0002. Pretty cool, huh? That's how IPv6 works. And if it was an A here, it'd be a different network. If it was a C here, it'd be a different network. The network portion is unique, which defines a different network. That /64 just tells you how far is the network and all the available host addresses. But what are the host addresses? I'm still confused. Well, what it comes down to, with that network, the host addresses is from zeros up until the last possible. And the last possible is all Fs. Which means our values can go anywhere from all zeros up until all Fs, because all Fs is the last character possible in hex. So that means our values can be 1, 2, 3, 4, 5, 6, 7, 8, 9, or after 9, A, B, C, D, E, F for each and every one of these placeholders. That's going to give us an insanely amount of like cajillions of addresses just for a /64. Not really cajillions, but at least more than many million. And the way to do your math is just like we had in IPv4. Well, how many bits are there total in IPv6? There's 128. If 64 are network, then there's 64 remaining for host for this individual network. 2 to the power of 64 gives you your number of usable addresses in IPv6 for this single subnet. And that's more addresses than there were in the world for IPv4 that you get just for your 001 network. Ironic, huh? Kind of cool. So that's how we understand the networks, and now we just roll out and do the configuration. So on R1, we're going to configure our addressing. I'll go into R1, and this is a really quick lab. Enable global config, interface gig, do it right, gig 00, no shut, and that is the interface on the left. We're going to go ahead and put 2001 DB811:1. So IPv6 address 2001 DB811:1/64 with no space. No shut, we already did that, but we'll do our link local address. What is this link local thing, this FE80:1? This is an address that can be used again and again on a router, but the rule is it can only be used once on each local network. So on router 1 here, we're going to tell router 1 that you will respond to your local network down below on the left. If someone reaches out to FE80:1, you'll say, yes, that's me. And then we're going to put that same address on the right of router 1 and say, hey, router 1, if anybody reaches out to FE80:1 on this network, that's you. But how can you use it twice? That doesn't make sense. Each local network can use that address only once. So if CAD or engineer or design calls out to FE80:1, router 1 responds. You can't have FE80:1 on CAD and on router 1. That won't work. It has to be unique. It has to be unique for the network it's on. At the same time, sales, billing, accounting, if they call out to FE80:1, it is only configured on router 1. So sales, they can't use FE80:1 configured on itself at the same time the router has it, because then it's a duplicate on the local network. This allows sales, billing, and accounting to target a default gateway of not 2001 DB811:1. We can have sales, billing, and accounting target a default gateway of FE80:1. The same default gateway design, engineering, and CAD are targeting, because FE80:1 is configured on the router. So for each local LAN, that address is unique. For each local LAN, that address only exists once, and it's on the router. So it makes connectivity even easier. Our routing protocols also use this as well. So back to router 1. We did our global address, which is at 2001 DB811:1, and now we'll say IPv6 address FE80:1 link -local. We tell the router that's a link local address. People can reach you on it. I'll back up one level, go into the next port, gig 0/1, no shut, the one on the right turns on. I'm going to up arrow and refire that link local command. I'm going to up arrow, and then for that global address, it's no longer 2001 DB811:1, that's network 2, 12:1/64. Why make life difficult? Make life easy. At this point, I'm going to take a look at that. There's a WAN port, that serial, that needs to go up. Can't forget about that. Back up, interface serial 000, no shut, we'll see it go green. We're not done, let's put our addressing on it. I can up arrow again to make my life easy, link local, drop it in, up arrow again, global unicast, this one is 2001 DB8, got that, 1, and then instead of 2, it is A001:2, where that second address in IPv6 with a /64. Awesome. I'm going to back up one level, and I want to make sure IPv6 is activated on the router. To do that, we say IPv6 unicast-routing, enter, and that actually turns on IPv6 forwarding and routing of addressing. So lastly, we'll do the servers and clients, it looks like here. Just make sure that items below have the correct IPv6 addressing info. Also, you'll see the default gateway is targeting the router's link local addresses. So even though sales, billing, accounting are on a different network than design, engineering, CAD, they're all using the same default gateway target because R1 is responding as FE80:1 on both of its links. Makes life easy. So we'll go to sales, IPv6, and for that, can I copy paste? That would make my life easy. Looks like I can. So sales, we'll go ahead and, nope, we'll do it manually. 2001 DB811:2 and /64. Link local address for us. Well, they don't really give us our link local address, so let's go with a guess here. I'll be FE80:A. Why not? It's not case sensitive, by the way. Capital A is the same as lowercase a. And the router would be FE80:1, as we see there. I'm going to make my life easier by copying that global IPv6 address, and we're going to change that up as we move across the different devices. So close that off, close it off. Billing, we'll go to that next, IP, and paste. Instead of 2, billing is actually 3. 64, FE80:B. I'll be the next one. We can't duplicate the link local addresses on a single network. So sales was A, the router 1 is already 1, and I'm just going to make billing B. And then default gateway of the router, FE80:1. And close that off. Accounting. Accounting is going to be the 4th address. So there we go. Change it to 4. 64. I hope it's not creating the link local for the local address. This one populated automatically. This is being built using the accounting server's MAC address, and then it's padding it with FFFE in the middle. So we'll see. Hopefully we're not being downgraded on the first two. FE80:1 is the router's link local IPv6 address, and we can close that off. Now we've got the last 3, design, engineering, CAD. Design is going to be the 2 network, :2. So we'll go there. So this is going to be the 2 network, :2 /64. FE80:A. I can reuse that because I'm on a different network now. FE80:1, which is the router's link local, even on the right side. Close that off. Engineering. IPv6. Engineering is going to be 2:3. So we'll change that. We're in the 2 network, :3 /64. Link local, FE80:B. Even though that's the same as billings link local, that's on a different subnet. It's a different LAN. We can reuse because it's not being reused on a single LAN. That address exists on another network. The router is responding, as mentioned, on FE80:1. Good. CAD is address 4. So we'll go ahead and do our IP config. And we'll take IPv6:4 /64. You see the server here is auto-populating its link local address using its MAC address with EUI64, which means pad it with an FFFE. Default gateway is still router 1, FE80:1. Cool. And that's looking good. Now it looks like I'm being downgraded on one thing here. I wonder if it's at ISP. I'm going to double check that to see. But we might be missing something somewhere. The very basic config. Let's take a look. IPv6 gateway, addressing, sales, billing, clients, design, engineering. It might just be a test, perhaps. So I'll go ahead and give that a try as well. Let's see. We're going to click sales, click desktop tab, close the IP config window, and click on the web browser. So let's go to sales, web browser. And here we're going to type in the target 2001 DB811:4. Hit enter. We do have access to the accounting server. That's good. Let's see. 2001 DB812:4 should take us to the other server. We do have access to the CAD server too. We're going to try to ping the ISP. We're going to go to any client. Well, we're on the sales client right now. We'll open up a command prompt, and we're going to ping out to the ISP 2001 DB811A001:1. And we do have reachability. So everything's working beautifully. Let's see the check results and see what's happening here for the assessment item. Startup config. It wants us to save our work. What router is that on? That's router 1 where we've been working. To save our work. It's super important. Why? Because if you don't save your work and the router reboots, you've lost everything that you've done. And there is a step here where it does ask you to save it, so this is being graded for a reason. So to save our work, it's as easy as WR. Enter, which is short for write config, which is short for copy run star. So many ways to do it. Once you save your work, you're at 100%. We've tested full reachability. I hope you've enjoyed this video. Let me know if you have any questions. I love making this stuff. Have an awesome day.